Hello world, my name is Hernan. I'm an AI specialist software engineer with most experience in deep learning field. Today we are going to talk about latent diffusion models, how they work and how we could deploy an AI solution like this. First, we need to start talking about diffusion, how the model is capable of creating a new image from a text description. Well, imagine that your friend starts telling you a history about how he spent his vacation in the mountain. Somehow, using your friend's storytelling, you can imagine that in your mind, right? This is because you are using your own experience to create an image in your mind using the details, objects, colors, and shapes based on your friend's history. But the image that you imagine will never be as exact as your friend's life experience, because you were not in that place with him. That ability from us humans to image based on experience is the same that this model is making here for us. Well, how does the model store experience and how does it use it? The model transforms the text input into a vector using the text encoder, for example, clip encoder from OpenAI. That makes available a vector which represents the text image that we want to generate. The model, the diffusion model, was previously trained with image and captions. So in the latent space of vectors, a text description will be close to the kind of image that the user wants to generate when he inputs two people on the mountain. For example, in the story of your friend, we need to create an image with mountains and people. Any dream with that kind of information is a good image. So the model starts creating the desired image from nothing, from noise, and the input text vector all in the latent space, until some iteration the dreaming process finishes and the system creates the desired output. Take into account that this model is imagining or dreaming the output image every time you ask it for the same text, you will have a different output. It's the same like your friend telling again his history a couple of days after he traveled or after he talked with you. You will remember something different or will change some detail and the image in your mind will be different. Well, the PoC available in this repository use a FastAPI backend to serve the frontend to the user that could request any image from their cell phone or PC. After the image is requested to the backend invokes the AI model to produce the image and return it back to the user. This is the application that you will find in the repository, and in this case, in this POC, we are talking about one only service that is deployed on cloud to serve the backend frontend and the AI model. But now we are going to talk about which resource is needed for this and which option do we have. The user could consume this kind of service from a normal cell phone or a home PC, or maybe from something more industrial like a Jetson device or NVIDIA device. This kind of deep learning model will need a high-performance CPU and GPU to run. So not every user device will be able to execute it without a cloud service, because not every device, not every user has a GPU, for example. So could we deploy the model? Which option do we have? Well, at the end we have two options, and we are talking about in the future a third option. But starting from this point, on your left side we have the cloud computing option that is about deploying our model as a service in some cloud provider like GCP, Azure, AWS, or having our own virtual private server in the cloud. On the other hand, in the right hand, we have the edge computing option that is about deploying the model or part of it in the virtual using in the final user device or edge server to inference the desired image. Both options had advantage and disadvantage. So let's talk about edge computing. Edge computing is a great option if you need real-time response or reduce bandwidth or be able to work without internet connectivity. This is a common scenario or need working with video analytics because there is high traffic volume of data and you need real time to analyze them and act. And also this kind of solution give you data privacy because all data used is stored in the device inside your private network and there is no traffic shared between you and the cloud by internet. But for this solution, you need a high performance device on each location, something like a edge IoT device with GPU, like NVIDIA device. And well, could not be your case if you are planning to open your service to a normal user in any location. Also in edge computing, let's say that the cost is fixed because depends on how many devices you buy or how many locations you have to cover. After you buy the device, the cost is done, but obviously you have to maintain that device. Maybe 2 years before, after that, you have to buy more devices, but let's say that it's a fixed price. Obviously, then you will have a cloud fixed price, depends on how many devices you have, because you need some cloud service to manage and monitor those devices distributed in the world. Well, regarding cloud computing, it's a great option when your final user will always have internet to consume your service. You will have full control of your service because at the end it is deployed on the cloud platform and not in device distributed over the world. But in this case, you have to manage very well how to scale every part of the solution, backend, APIs, database, the GPU instance for inference, and always keep in mind that in this topology, you are more open to security issues because it is available for anyone with internet access. In cloud computing, the cost is variable because will depends on the demand and how many resources you let available for scale. And in this case, you have to manage how to scale your backend, your frontend, and your GPU instance for every part of your solution. And well, talking about resources, for both cases, edge or cloud computing, in this particular case, we are talking about NVIDIA A100 alike GPU for each instance. The best option is making something in between the pure edge or cloud solution, a mix of solution. If your final client device is power enough to make the test encoder and final decoder process with CPU only, you could serve an endpoint on cloud only for the diffusion decoder inference using the GPU on cloud, available on cloud. This will allow you to scale more your solution because at the end, the information that is sent over the internet is little compared to sending to the client the final image. In this topology, you are sending and receiving embeddings, and the client could recreate the image of any resolution without limitation of bandwidth. At the end, no matters if you take the edge or cloud computing strategy, that will depend from my understanding and how many locations you will like to serve your product or service, or about security, or about data privacy, or about open to all world. But at the end, you will use some frameworks to achieve your needs. In cloud or any edge device, you will use operation system sure based on Linux, and a part of that you have to install or handle the SDK of your GPU provider to optimize your model execution, like NVIDIA TRT SDK, OpenVINO of Intel, or using OnNX to import your model to any format. In cloud or edge device, you have to deploy your model and your backend and frontend application. So for sure you will need a Docker and maybe also Kubernetes. For edge or GCP cloud solution, you will have the possibility also for TensorFlow serving. Also, you need to monitor your solution in the field, in cloud, or distributed in edge devices, and create reports to measure the quality of your service. For that, you could use Prometheus for monitoring and Grafana for dashboard reports. If you are using an edge device strategy, you will also need to push your monitoring data into cloud using something like Kafka or MQTT, some publish or unsubscribing protocol. If you follow my previous recommendation about frameworks, you will be able to complete the machine learning ops process. You will be able to train and deploy your model, and after that, monitor and retrieve information to retrain again and improve your solution, your service. This kind of practice will help you to reduce bias in your data and your service. For example, talking about something very simple and related to this case, generating image from text. If someone requests you to create or generate an image of a torch, it could be a fire torch or a flashlight, and the output should depends on the dataset used to train your model or the customer context. At the end, depending on the customer context, the user will be expecting a flashlight or a fire torch. So you have to retrain your model depends of the final client that you are pointing on. Well, this is the end. Thanks, and I hope you're enjoying this little talk. In my channel, you will find more videos about AI like this project, other projects related to deep learning. You can also go to my GitHub or to my blog to retrieve more information or see another POC that I have available there. So thank you again, and bye. See you.